finish. Finish sooner we shall. You get my Yoda impression? Okay, so it says the tank has a height of 10. The area of the cross section at height h is given by a function a, where a is measured in square feet. Okay, then it says a is continuous and it decreases. Select values of a are given in the table above. Okay, part A. Use a left Riemann sum with 3 subintervals indicated by the data in the table to approximate the volume of the tank. Okay, question. Lots of weird crap. What's here? Stop. What's here? What does A stand for?
Area.
The area. Okay, good. What are we asked to find in part A? The volume. How do you find volume when you have area?
Area times height.
Integral. Very good. Close. So I'm going to do area equals the integral of a of h. Now, if this is an h, then my endpoints have to be h's. Where is my h between? How tall is it? 10. So from 0 till 10. Okay, so keep in mind that I'm putting 0 and 10 on my endpoints because that's my letter. That's like my x, right? Okay, and then dh. Now, they tell me how to approximate it. They tell me to do a left Riemann sum. So if I were to break this up, 0 to 2, 2 to 5, 5 to 10, do I have the same delta x or is it changing? Changing. So 0 to 2, my delta x is 2. 2 to 5, my delta x is 3. And then last one, delta x is 5. And remember that whenever they change like that, you have to do separate base times heights. So for my first one, 0 to 2 is 2. And then which is my left y value for me to multiply by? 50.3. Good job. K plus. Then from 2 to 5, my width is 3. My left y value is 14.4. And then for my last one, from 5 to 10, my width is 5. And then my left y value is 6.5. So remember, whenever you're doing Riemann sums, it's delta x times the y. Delta x times the y. Delta x times the y. Okay? Then you can add it up if you want to, but you don't have to. Okay, part B.
How many more minutes do we have?
Like 30-ish.
I'm gonna go ask Miss B if
She's probably already gone, but you can text her on my phone.
Okay.
Okay.
I'm obviously gonna finish in 30 minutes.
Yes. Okay, part B. Does the approximation over or underestimate the volume? How do you tell if a Riemann sum's over or under?
The slope.
Whether it's increasing or decreasing. Now, they told us what is A doing? Decreasing. Also, you could look at the y values. What are they doing? They're getting smaller. So as my graph goes down, split it up.
Batman? Seriously, Batman?
What about Batman? Okay, I'm in the middle of a thing, baby. Yeah, I call Batman sometimes. Okay, refocus. Mind your business. Okay, we're doing a left Riemann sum. So that means that when I do my rectangles, I need to use the left height. Is that going to make it too big or too small?
Too big.
Too big. So for part B, I would say it's an overestimate.
Can I call Batman?
No. Because, and then remember, there are two things you have to...
Because why, Mom?
Ashton, I'm in the middle, I'm videoing this.
You said because why?
I'm about to take my phone back.
Because what?
Okay. Because A is decreasing.
That does not make any sense, Bob.
Oh my gosh. And the left y value is the greatest or the least on each subinterval if it's on the left.
Great.
Is the greatest. On each subinterval. Okay. So A is decreasing. That means the left y value is always the biggest. So overall, it's an overestimate. Okay, part C says the area in square feet of the horizontal cross section at height h is modeled by. Now they're giving you a function. Now notice we already had area up here. Now they're changing you and giving you a different model. So it says this is the area. Why they decided to pick the letter F, nobody knows. Okay, but area is F. Then it says, based on this model, find the volume of the tank. So if I have area, how do I find the volume? Integral. Yep. Okay, so for part C, I'm going to do volume equals the integral from 0 to 10. And this time, instead of me using a Riemann sum, I'm just going to type the integral into the calculator. So if you haven't already, go ahead and type that in. And then DH. And then if you haven't typed it in yet, go ahead and put it in your y equals, because we're going to use it again in part D. So remember to do that. We're going into y equals here. And then we're doing alpha y equals. We'll pull up the little fraction bar. And then n over d. So alpha y equals to pull that up. And then from there, remember you're integrating 0 till 10. So math 9, 0 to 10, alpha trace y1, dx. So my model using that equation tells me that the volume is about 101.325. 101.3253. Now it says to indicate units of measure. So what did we just find? It was a volume. So what unit would that be? If it's volume. Yeah, 1 up from squared would be cubed. Cubic feet, or if you wanted, you could do feet and then the little cubed, it doesn't matter. Okay, so remember that if it's volume, it's cubic feet. Square feet goes with area. Okay, then go to part D. Okay, last one, part D. What I want you to do is try to fill in your find given one. Do you guys want like a cookie or something? I'll bring you one. Okay, try to fill that out. So, find given one. Okay, just chill. Okay, you can either have a dum-dum or...
Are they still the expired cookies?
They're the same cookies.
Wait, there's no more chewy?
They're no more chewy. Okay. And they're not expired, okay? They're just a little
Stale.
crunchier than... Are they stale?
That's the
No one
word.
knows, okay?
That's the one.
You can have two.
I'm not ready to turn that down.
Ashton, you want a cookie next?
Mom, where's the packaging?
Where's the what?
The packaging that went around that.
I threw it away and I put it in this Ziploc. You want two?
Oh, man.
Do you want one, babe? Ash?
Trust me.
Oh,
It tastes
sweet soda.
delicious.
It's still a cookie.
Yeah.
Yeah, look,
Oh,
high
I mean,
school,
when you think how many
you can't be
preservatives
a
they
cool
put in
kid if you don't eat the stale cookies.
The one that you made was
Maybe I'll make
Yeah, I just took a... I brought it here.
So it's next day after they
Because pretty much everyone that takes the AP test should be exempt. So that only puts like 6 people testing total out of both of my classes.
Wait, really?
Almost everybody's testing. Okay, so, huh?
like 35 and then less than 3 days, right?
Yeah.
But I thought if you take AP test, you're exempt.
No, you have to still have above an 80 because of quality points and other stuff.
Study sessions
Oh,
were
really?
like...
Yes. So if you're here, then you're going to get out of it for a different reason.
Oh, are
But-
you serious?
Yeah, that's the point of
Wait,
these.
what if I didn't take the AP test? But I-
Then you wouldn't have been able to. I made an exception on 2 people, but it's a secret. So I just put it in this video. So obviously I'm not very good at keeping secrets. Okay, focus. What are we finding in part D?
Oh,
Or honestly, I'll take anything. Find the rate at which the...
The volume of water is
Okay, so we want dV/dt, right? Okay, then what rate were we given? or the when. I'll take either one.
Is it just that?
Yes, the height is increasing at a rate, so that's dHdt, is 0.26. Notice that's feet per minute. If you want to keep track of that stuff, you can. Okay, so feet per minute, and then what's my when? Oh, I didn't hear you, sorry. And then what's my when? When height is 5, good. Okay, now, this is a little tricky because they didn't give you an equation. You have to go back to geometry on this one. How do you find the volume of anything? You do the area of the base times the height. So you should know that. But volume is the area of the base times the height. So think about, what am I going to use for my area? Well, it says use the model from part C. This is my area. So my volume is going to be 50.3 e to the 0.2h plus h times h. And actually, it might be easier, instead of calling it that, let's call it f of h times h. Just so that it's not so much to write.
Height is just 5, so.
Yes, but keep in mind that when you take the derivative, you are going to have to do product rule. Ash, come on, dude, stop. Okay, so I'm going to break this up when I take the derivative. What's the derivative of v? d v dt. And then here, I'm going to break this up into a product rule. So my u is going to be f of h. My v is going to be h. And then when I take the derivative, what's u prime going to be? F prime of h times what? This is the tricky part. d h dt. Because remember, if it's not a t in the middle, you have to put a chain rule on the end. So the derivative of f of h would be f prime of h times dh dt, which is like what h prime is in the middle. Okay, then over here I had an h. What's the derivative of h called? dh dt, very good. So I'm doing product rule on that because my function was f times h. So from there, it's, we'll do this diagonal first. F of h dh dt plus, and then f prime of h dh dt times h. Okay, so kind of tricky on that because you did have to remember to do product rule. But remember that if you'd taken the derivative incorrectly but you'd labeled stuff, you still could have gotten partial credit. Okay, then from here, where am I going to get my values if I plug in 5? How will I know what f of h is? It's in the table, very good. So I already have it typed in here. I'm looking in my table. Go down to 5. My y value is 6.5169. So that's what I'm going to put here. 6.5169. Then what's my dHdt? They gave me that.
That's
0.26 plus. Then when I get to my f prime, where am I going to find that in the calculator? I have f typed in. I need to take the derivative. Good. So for f prime, I'm going to do math 8 d dx of my function y1 at, and then I want it at 5. Because remember, f prime of 5 would be like the derivative. So negative 1.3033. Okay, then I have another dH dt sitting right here, so I need to remember to do that. So another dH dt is 0.26, and then what's my h? 5. Now, keep in mind, you don't have to times that out. You can leave it just like that. Okay? Then it did say to indicate units of measure. So if this is dV dt, what would I put for my units of measure? Squared or cubed? Cubic feet per minute. Yeah? And remember, it's cubic feet because it's volume. Over here, you could put dV dt at h equals 5. That's probably how I'd label that, but if you didn't label it, I don't think you'd lose a point or anything. Good.
How come you put 6.5? Like, if you look at the table given up, they only give you 6.5, isn't that?
In my table it puts 6.517. Oh wait, hold on. What number was it at? Yeah, 6.517, right? Yours only says 6.5?
No, like on the graph that's given.
Oh, okay, so these aren't the exact same model. So if you look at like at 0, oh yeah, it is exact. 2. Yeah, so it looks like they just rounded up here. I would make sure though that once they've given you the equation, you're on the 3 decimal place rule. In the table, they only gave you 1, so you get to only use 1. But if they're giving you an equation, I would at least do 3 every time.
So even if they give us, like what 5 equals, just go ahead and take it.
Yes, because normally they wouldn't give you a table and then also give you an equation. That's what was kind of weird on this. If you had used 6.5, they might have had enough kids do that when they took the AP test that they would have just left it. But usually they don't give you a table and an equation. Usually it's one or the other. Okay. Next one we're gonna do. Let's do these. I've done a bunch of those. Let's go to this one right here. Okay, so it says f is differentiable on the closed interval, and f of -2 is 7. Okay, I would automatically, when I see this, be thinking about a version B. Okay, if they're giving you a value of f, you're probably going to use that in a version B somewhere. Then it says f prime has the derivative, it has a semicircle and 3 line segments. Okay, find the values of f of -6 and f of 5. Now notice, I want f, I have a graph of f prime. What am I going to have to do? Y value derivative integral, which one? I have f prime, I want f. Integral, so that's a version B. So I want f of 5 first. Okay, well what y value do I already have? F of -2. And then I'm going to set up the integral from -2 to 5. And then remember, what goes in your integral should be the derivative of what's on the outside. So if these are normal f's, this should be f prime. Good? Okay, then f of -2 is given to us. They said it was 7 plus. And then for this part right here, we're going to do area. So from -2 to 5, I'm starting here, and I'm shading until here. So I have 2 shapes. For my semicircle, remember it's 1/2 pi r squared.
You did it again.
Who did?
I messed up again.
And then what's my r on that? 2. So 2 is right here, 2 goes in the middle. 2 squared is 4 pi, half of that is 2 pi. Okay? Positive or negative on that?
Negative.
Negative. So -2 pi plus, and then I'll do my triangle up here. Remember that that's going to be 1/2 base times height. My base is 1, 2, 3 across. My height is 2. 3 times 2 is 6. Half of that is 3. And you could leave it like that if you wanted to. You could put the 7 and 3 together, call it 10 minus 2 pi, but you wouldn't get points off if you left it. Okay, find f of -6 now. Same version B, but you're going to notice something is wrong with your integral. So I'd have f of -2 plus the integral from -2 to -6, f prime of x, and then I notice that my integral here is backwards. So when you calculate your area, you have to remember to switch the sign on it. So I'll have 7 plus, and then I'm looking at my, if I'm going from -2 to -6, what shape is that? Triangle. So it'd be 1/2 base times height. My base is 4, my height is 2. 1/2 4 times 2. We get half of 8, which is 4. Plus or minus 4?
Plus.
Minus, good. Because remember, it's backwards.
Yeah.
So even though it's above, it counts really as a negative. Okay? So that'd be your answer for A. Okay, part B says, on what interval is f increasing? So remember, if f is increasing, we care about f prime. This is a graph of f prime. So where do I want f prime to be for f to be increasing?
It's above.
Above the x-axis. Where does that happen for part B?
-6 to -2.
Okay, -6 to -2, union
2 to 5.
2 to 5, good. Because f prime of x greater than 0. Okay, which is the graph that I was given. Okay, part C says, find the absolute minimum on the interval from -6 to 5. Okay, so remember, absolute minimum, I need to check endpoints. So I'm going to go ahead and set up a candidates chart here, because I know I'm going to have to do one unless there's only one critical number, but I can already see looking at the graph there are 2. Now, which of those is going to be a minimum to go in my chart?
2.
Positive 2. This one is a minimum. You can put -2 in there if you want to, but if it's a max, you know it's not going to be the winner. Okay, so I'm putting -6 and 5 in my chart, and then I'm also putting 2 in my chart. Now, the other thing that I think you should say is I'm going to put, we have a relative minimum at x equals 2 because f prime changes negative to positive. And so you're basically saying, why is 2 in the chart? Because that's where I have a sign change that shows I have a relative minimum, but for absolute, you have to check all your y values. So put f of x here. I don't know, it just kind of depends. So I'd say just do it just in case. Sometimes they get points for that, sometimes they don't. I'd say more often than not they don't give points for it, but yeah. So you're saying, why am I picking 2? It's a relative minimum. Now let's do our table. Do I need to re-find these values?
No.
I already found those 2 in part A. F of 5 came out to be 10 minus 2 pi. And f of -6 came out to be, what, 7 minus 4? 3. Good. So really, I only have to find one more value, and it's f of 2. So if I find f of 2, it's one more version B. It'd be f of -2 plus the integral -2 to 2 of f prime of x. F of -2, it said, was 7. And then for my thing, we know it's 2 pi. Do I add or subtract it? Subtract it. So that'd be 7 minus 2 pi. Now, using your reasoning skills here, which of those is the smallest? At 2. Very good. Because think about 2 pi is about 2 times 3. It's like 6 because it's 3.14. So if I do 7 minus 6, that's going to be 1. Versus 10 minus 6, that's going to be like 4. So we would say the absolute min is 7 minus 2 pi at x equals 2. And that would be your answer. Okay? And then remember, if you label your chart, you don't have to say a bunch of extra crap. It's the smallest value in the table. As long as your chart's labeled, that's good enough. Okay, last part of that one, part D. Says for f double prime of -5 and 3, find the value or explain why it doesn't exist. Okay, f double prime of -5 is what in the graph?
-1/2.
Okay, how'd you get that?
The slope.
It's the slope. Very good. So when I come back up to my graph here at -5, that's right here. Remember, you should always count the slope from the endpoints, or the pretty points, as McDaniel calls them. So if I start here, I have to go down 2 and then over 4. So that's a slope of -0.5. And remember that if this is f prime, then f double prime is the slope of that. So -0.5. The other one that they asked me for was f double prime of 3. What happens at 3 though in the graph? Corner. So what's the slope? DNE. Okay, do not put because corner. Put a sentence. so that it makes sense. I started taking off for that because people kept doing it. So because f prime has a corner at x equals 3. Okay.
Yes.
Good. All right, last one that we're going to do is the last page. The one with the differential equation. One more left. Okay, first question, we need to do a slope field. What's going to make it 0?
0.
Okay, good.
1.
So when y is 0, so I'm going to put my 0 slopes are going to be when y is 0. Now, what is going to make it an undefined slope?
X.
If x is 1. But notice here, what did they do? They left it blank. Okay, so those are blank on purpose. Don't put anything there. So y is 0 here and here. So I'm going to draw these flats in. And then for these guys, remember, these are easy points, even though they're annoying. You just plug it in. So this is 2, 1. This is 2, 2. This is 0, 1. This is 0, 2. And you just plug each of those into your slope, find what the slope is, and then draw a line segment. So if I'm doing 2 squared over 2 minus 1, what's that going to be up top?
It's going to be 4.
4 over 1, so we'll make that uphill. Then plug in 2, I'd have 2 squared over, 1 squared over 2 minus 1. And 1 minus 1 is 1. So your 4 should be steeper than your 1, right? Okay, then on the other side, we're doing 0, 1. So that'd be 1 squared over 0 minus 1. And that would be 2 squared over 0 minus 1. Okay, well, 2 squared on top is 4. So that's a negative 4 overall. And then that's a 1 squared is 1 over negative 1 is a negative 1. And then just keep in mind, your 4s should be steeper than your 1s. They should be going the right direction, all that. Okay, part B. You're asked to let y be the particular solution. F of 2 is 3. Write an equation for the line tangent to the graph of f at 2. So what 2 things do we need?
Zoom out.
A point and a
So,
slope. Good. And notice that they're not up here saying f is the particular solution. They're not asking you to do anything with that. So my point would be 2, 3. They already gave me that. And then where do you find the slope? Yep. Go back to the dy dx. Yep. And plug it in. So 2, 3, I'd have 3 squared on top over 2 minus 1 on bottom. 3 squared comes out to be 9. And then from there, you're writing an equation of the tangent line. Make sure that you write it first and then plug into it. So it should be y minus 3, slope of 9, x minus 2. So we wrote the equation, then it says to use the equation to approximate. Then I'm taking f of 2.1, and I'm taking that decimal and plugging it in. Then remember that if decimals aren't your thing, you really don't have to do much work with it. The only thing you have to do to solve is what? You have to get y by itself. So if there's a minus 3, I'm just going to plus that across to the other side. Now, you could leave it like this, but if it was multiple choice, obviously they wouldn't. So 2.1 minus 2 is how much? 0.1 times 9 is 0.9. 0.9 plus 3 is 3.9. Okay, but if you got to there, you would have been fine. Okay? Last part, part C. Okay, it says find the particular solution given the initial condition. So what do you need to do first?
from the particular solution.
Yes, what do you do first though?
Oh, yeah, split.
separate.
Yeah.
Okay, think about particular, apart, maybe. Okay, just made that up. You're welcome. So, if you have dy dx, y squared over x minus 1, that has to be separated. So just do that first step for me. Okay, step 1, what should your separate look like?
1 over y squared dy.
Yeah?
1 over x minus 1 dx.
Good. Make sure that your x minus 1, if it was already on the bottom, it's got to stay on the bottom. So you can leave a 1 above it as a placeholder, okay, but they're both on the bottom. Now, the way that we do the integral is get a change based on which side we're on. Which side needs u sub? Only one of them.
Right.
Yes. The right side, correct. The left side, how can I avoid u sub?
Just put it to the negative section.
Yep, good. So on the left side, you're going to rewrite that as y to the negative 2. Okay, so remember you're going to add 1 to the power and then divide. So if it was y to the negative 2 and I add 1 to that, what do I get?
Oh, negative 2 minus the negative 1.
Close. You're going to add 1 and then divide by that.
Oh,
So you're not going to divide by the 2, you're going to divide by after you've added the 1. And then keep in mind if you're dividing by negative 1, that's the same as multiplying, it doesn't matter. Okay, other side. Actually, I'm going to do one more step on that and write that how? As 1 over y negative. Because that's the same. Okay, other side, what would I pick as my u?
x minus 1.
Good. U is x minus 1. That means that du is 1 dx. And anytime that du is 1 dx, that means that dx and du are the same. So when you switch letters, you don't have to make any weird changes. You won't have any extra numbers sticking out or anything. So it'll be 1 over u du. And then what's the integral of 1 over u? Yeah, natural log u plus c. And then I have one more step. I have to bring my u stuff back to x's. So if my u is an x minus 1, I have to go back and plug that in. Okay, what would we do next? Should I flip both sides right now?
Let's multiply.
Yeah, I'd get rid of the negative first. So I'm going to multiply by negative 1. That turns my 1 over y to a positive, but it turns my natural log x minus 1 to a negative. Now, the c, should I change it to a minus c? You can, but useless, don't do it. Okay, from there we're going to flip both sides. So this is all over 1 together, so I'm going to flip it all together. So when I flip 1 over y, I'm going to get y equals, and then on that side I'll have 1 over negative ln x minus 1 plus c. That's your general solution. What did they ask you to find? Particular, which means that we are not done. We have to find our c. So our point is 2, 3. So that means that 3 is the answer when I plug in 2. Okay, well, what's 2 minus 1 in there? 1. So I have 3 equals 1 over negative ln 1 plus c. What can we do next?
The negative ln 1, which is 0.
It is 0. Now let's pretend like you didn't know that. Could you leave it in there and just solve for your c to have an ln of 1 in it? Sure. Okay, if you don't know that it's 0, not the end of the world. But it is 0 and it does make it easier. So ln of 1 is 0. That means really that I just have 3 equals 1 over c. And then if I reciprocal the c side, I have to reciprocal the 3 side as well. So when I flip this, I get c equals. Flip that, I get 1/3. So then I'm going to come back to my general solution and I'm going to plug my third in. So it'd be y equals 1 over negative ln x minus 1 plus a third. And that would be your answer. Good?
Yes.
Remember these things? All right. Well, it's 4:55, so let y'all go a few minutes early. Well, ln of 1 is 0, so the negative doesn't make a difference. And do you know how you can remember? Because, okay, so e to the x goes through what point at 0? What's e to the 0? 1. Then ln is the inverse of that, so it has to go through 1, 0. So if you remember, e to the x goes through 0, 1, then ln x has to go through 1, 0. Because they're inverses of each other. So their ordered pairs are always backwards. Boom. I bet it.